Hi, this is Kelly Fernandez. Assignment 2. Here's my demonstration of the Simacago game. So I've represented the game as a human player, an AI player, and a board. The board consists of the board size, which I've hard-coded, a two-dimensional character array, a reference to a current player, a reference to the next player, the move that generated the current state of the board, and I also have a boolean to say whether or not this is a root node, and I also have included an optional value if you want to save the value of the board game. I also have a human and an AI player that both extend a player class. They each have a take turn method that increments the number turn, which is used to determine when the game is over. Their column selection, and then the board is updated here for the player. Each player has a reference to a board, their own board, just to maintain the state. I also maintain their marker, who their opponent is, and the number of turns that they've taken. So if I start my game here, first I'm asked how many plies deep do I want to have the AI look forward. If I put 2, that's actually going to be equivalent to 4 moves, 2 for each player. So first it prompts the human player, your turn, please enter a column that you'd like to choose. I'll choose 2 here. And here is my human move, X black. I've chosen column 2 in normal non-computer counting. And the AI then responded with a move of 0. Now I'm again asked what move. I'll choose column 3, and the AI also responds and chose column 2. Actually, this should read 3. I'll correct that. I just manually increment in my code. And this will continue. Keep choosing moves. I chose 5, which doesn't give me any points. And it'll continue to play. For brevity's sake, I've only implemented 10 moves in this case. I'll change this when I turn my assignment in to do 40. Game over, so the AI scored 24, I scored 17. So the AI won. Here is my mini-max algorithm. Here's my main algorithm that's called the do-min-max, implemented with alpha beta. So basically I'm given an initial board state and a depth that I'm supposed to look. If I'm already at my maximum depth, I'm going to run the eval function. If not, depending on who the player is maximizing or minimizing, I'm going to examine the child or successor moves for the board, which I've calculated here in this board get open moves method. I'm going to create a child node here given the moves, because I'm just giving you moves two-dimensional or 2 coordinates in an array. I'm going to recursively call my do min max function on the child end board, and then it's going to repeat and so I'm going to then end up in my minimizing function. I'm going to continue to recursively call until I get to my specified depth. Here in both the minimizing and maximizing function, I check whether or not the value, the calculated value, is greater than alpha or less than beta in my minimizing case, and if so, I'm going to save beta and I'm going to save alpha. If it's a root node, I'm going to return the move and the value, and otherwise, if beta is less than or equal to alpha, when I've saved alpha and I've saved beta, I'm going to return my alpha score. Meanwhile, I've also set, if I found a better value for a board, I've set best board in a member function, which can be retrieved by the AI player to determine the coordinate best move that he should be taking. The recursive nature of the do min max allows me to percolate up the tree.